Hi, it's Edutainium here, and today we'll be talking about acids and bases. We see acids and bases in our everyday lives, such as acids in cleaning agents, fertilizers with nitric and phosphoric acid, preservatives with citric acid, and foods like vinegar, also called acetic acid, and cheese containing lactic acid and carboxylic acids. Additionally, bases can be found ranging from your everyday toothpaste containing sodium bicarbonate to medical uses like calcium carbonate to treat indigestion. As to how that works, we'll talk about that later. We know that there are acids and bases, but how do we distinguish them? There's an easy way to do that. Acids are acidic, and bases are alkaline. Soluble bases can also be called alkalis, meaning they can dissolve in a solvent. pH is a measure of acidity or alkalinity. It ranges from 0 to over 14. pH means the potential of hydrogen, which means how concentrated hydrogen ions are in a substance. If you want to know what ions are, check out my next video. If H+ ions are more concentrated than OH- ions in a solution, the pH will be lower, meaning it's acidic. Vice versa. If OH- ions are more concentrated than H+ ions, the higher the pH, meaning it's alkaline. And one thing you must know, pH below 7 means acidic, pH above 7 means alkaline, and pH at exactly 7 means it's neutral, neither acidic or alkaline, like distilled water, pure H2O. However, just water isn't neutral, because it contains different minerals that might affect pH. Universal indicators are a way to measure pH. It is a mixture of a bunch of different pH indicators, like thymol blue and methyl red. If you have a solution, simply drop a few drops of universal indicator in, and the solution will change color according to its pH. This is a scale comparing colors to pH, so if you get a bright red solution, it's acidic. Purple, then it's alkaline. There's another thing called pH paper, which works quite similar to the universal indicator. It is literally a thin piece of paper that changes color when it touches a solution according to its pH, and the color scheme scale is just like the universal indicator. Have you wondered how you can make an acid or alkali? If you didn't already know, the elements of the periodic table are split into metals and nonmetals. When they react with oxygen, they become oxides. Well, why does this matter? It is because soluble metal oxides, when mixed with water, become metal hydroxides, where hydroxide is the OH- ion I mentioned earlier. This makes the solution alkaline, like sodium oxide for example. Sodium is a metal, plus oxygen makes it a metal oxide. And to make acids, simply do the opposite. Soluble non-metal oxides mixed with water make acids, like hydrogen chloride mixed with water makes hydrochloric acid. Remember how I said bases, or alkalis, are used for treating indigestion? This is an example of a neutralization reaction. Neutralization is when acids and alkalis mix to produce a neutral solution. Kinda like how a balance works. A lower pH mixes with a higher pH to balance it out, making it a solution with pH 7. Let me show you how it becomes neutral. NaO2, as mentioned above, sodium oxide, is an alkali, plus HCl, hydrochloric acid, makes sodium chloride plus water. NaCl is table salt, the stuff you use for cooking every day. And as I said, pure H2O is neutral. So now there aren't any metal or non-metal oxides in this product. That's why it's neutral. Indigestion is caused by acid reflux, so in order to make you feel better, alkalis like calcium carbonate are used by doctors to neutralize the acid. This is a summary of what we've learned today. If you found this useful, please consider liking this video or even subscribing to support future videos like this. Have fun with chemistry and see you next time!